Hi Kirsty, so this is a little run through of the hypothesis test for correlation. We can touch base on Monday just to tidy up any questions, but I thought it would be helpful to get the whole topic of hypothesis testing done so you can practice all three. So basically, quick revisit of what correlation is. It's a link between two different variables. So in this we've got an x variable and a y variable, and it's similar in science where one we call the control variable and the other is the response variable. So my favourite example is actually a biology one, if you ever did it in biology, where you have pondweed and you increase the amount of light that you give it, and the response to that is that the pondweed makes more oxygen, it photosynthesizes more. And we could say that has a positive correlation because as I increase one thing, the other thing decreases. Increases. A negative correlation is where you increase something and the other thing decreases. So if I increased the amount of time it took me to run 100 meters, my speed would decrease, and that would be a negative correlation. So what does it look like on a scatter diagram? Well, the more pieces of scatter, the easier it is for me to eyeball a particular correlation. So if I've only got two like this, well, I'd have to kind of guess that the product moment correlation coefficient, which is always between -1 and 1, would be something that's positive. But if I start to increase the scatter, we might see, in fact, that this might have a very weak negative correlation. So I need to collect lots and lots of data to be fairly sure by eye whether it's correlated or not. Now, what we might want to do is we might want to decide whether it reaches a specific standard to say that it is correlated in some way. And that's why we're going to do a hypothesis test. So, let's just have a little look at this example. The correlation coefficient between mass and the height of students, so that's an obvious one to say that we think that it's positive correlated, but they've calculated this value of R here, which is 0.85, and we're going to test it at a 5% significance level. Now, interestingly, instead of using R, we're going to use rho, because that letter represents how lots and lots of different samples of this situation would be distributed. So rho is the distribution of lots of correlation coefficients. Now, you definitely do not need to know anything more than just remembering that fact. It's not on the further maths syllabus. It's really difficult to look at correlation and its distribution, so don't worry about that. But what we're going to say, like we've done before, is that H0, we're going to assume that there's no correlation. And because in the question it says that we think they're positively correlated, we're going to say that we think this is going to be greater than 0. There's going to be some correlation to it. Okay? We then have to define what P is, what rho is, and this would be the correlation between height and mass. Okay, so we've done that bit. We now would go on and actually do some kind of calculation in a normal correlation. Sorry, I'm mincing my words today. In a normal hypothesis test. But in fact, because it's really complicated to do that calculation, they just want you to use a lookup table. So we are going to simply look at the value in the table and we're going to compare it with 0.85. So we wanted to do a 5% hypothesis test. It's one tail. And then here, this is the amount of pieces of scatter that we picked. Okay, so we're literally just going to read that value off, and you'll be given that in the exam. Sometimes they even take the specific part of the table and put it next to the question, which is quite nice. So if we've got n equals 6, that means we had 0.7293. Now this is the bit where it's slightly different to the other tests. We need to think of that value as like the minimum standard that your sample has got to meet to say that it's correlated. So our sample definitely meets that standard. In fact, it's better correlated. So our conclusion is that we're going to reject H0, accept H1. There is evidence to suggest a positive correlation between height and mass. Okay, so it's only this bit in the middle that's slightly different. We're used to accepting H1, where we've got something that's like really extreme, that it didn't have a very high probability of naturally occurring. But in this hypothesis test, we're using this as a guide, and we're saying if we can see that level of correlation in our data, it meets that standard. And if we look at the table, can you see that as you've got more pieces of scatter, the bar is lower and lower and lower, which is akin to what I was saying at the moment, at the beginning. As I increase the amount of scatter, it becomes more and more obvious as to what the trend is of the data. When there isn't very much data, I've got to be a lot more certain. The grouping of the scatter's got to be a much better fit for the correlation, or closer to a line of best fit. Okay? So I hope that's helpful and enough for you to at least have a go at doing some from the textbook. All right? Yeah, and I'll see you on Monday. Take care.